First. And yeah. Can you see my screen?
Yes.
Okay. Yeah.
Yes.
Yeah. Hi, everyone. So this is what we had implemented last time. So in Postman, basically, we could create a user and get their info, but we were storing their info in memory. I'll do npm run dev. Yeah. So we do this. So the user is created, but it's in memory. This user repo, this is in memory. So in today's lesson, we'll shift this to a proper database, Postgres, using Prisma. One of the problems of not having a database is that we can do multiple registrations like this. See, so now there are two records with the same email ID, and we want to prevent that. So having a proper database can ensure that no two records have the same email. So uh, yeah, so for the database, I'm using Superbase. Superbase is a very popular platform that provides Postgres for prototyping. It's very easy to have like a Postgres database. So yeah, so on the previous screen, so once you create an account on Superbase, this is the screen you get. So you basically do a new project. I will copy the password because we are going to use that later. So this is a password generated by Superbase, and yeah, I'll create a project. Yeah, while this is coming up, we can start working on our code. So uh, so we start by installing Prisma. Um, so I do, and yeah, our database is up. Uh, right now, as you can see, there are no tables. So we will first specify a schema, and then slowly we'll have our tables. I've just installed Prisma, uh, and right now there are no generated files, as you can see. So I'll give the command npx Prisma init, and see. So now there are several generated files. This is a TS file, but this is not part of our project. It is mostly used by Prisma as a command line tool, but not in our project. It generated a .env file for us where we have a database URL, and this is a Prisma folder where we have schema.prisma. Now here we have to change the provider because we are not using TypeScript. So Prisma client is for TypeScript, but since we are using plain JavaScript, we do Prisma client JS, and we can remove this output specification, uh, and we can start writing our models. So in the last lecture, we wrote a schema, user schema, but this was for validating the incoming requests. Similarly, in Prisma, we'll write our models. So we are storing a user and credentials. So we'll have two models, user and credentials. So we do model user. Uh, we have an ID int at this specifies that this field is the ID, and we'll have a default value of auto increment. So basically we had this ID here and we were incrementing it for every new user registered. So yeah, now this is what will happen in the database. Then we have first name, email string. Email should also be unique. So we unique, and uh, here we are inserting the created and updated timestamps in our program, but that should actually be provided by the database. So here we'll have account created, time, and default, and we'll have now. And date time, and this is updated at. We don't have created at, so we use default, and now is the timestamp at which this is being created. So this is our user model. It stores ID, first name, last name, email, account created, and account updated. And we also have another table for credentials. So we also provide an ID for credential. Um, and so in credentials, we store email, hash, and ID of the user. So yeah, email, which is of type string, again unique, of type string. And since we have already used the field ID, so here we'll use user ID, int, and this is also unique. Now we want to show that there is a relation between user and credential, right? The user ID here should map to the ID of the user. So we do that by writing this user. Uh, this will be of the type user, and write relation. So this user field will actually not be in the table, but in our model to show that this is a connection. So that is why this field is there. But in the actual database, I will show you, it will be only be these four fields: ID, email, hash, and user ID. So fields, user ID, uh, one moment. Okay, yeah. References. So field user ID references ID of model user. Um, just give me one moment. Okay, yeah. So it is giving us an error because I have specified that credential is related to user, but I also need to like specify user is related to credential. So we will have credential, and So right now, I I have not. So right now, this credential is not nullable. That means that if when the user is created, the credential has to be created. So in our user controller, we first create the user. Uh, yeah, we first create the user, we save the user, and then we hash the password, and then we save the credential. So uh, at the time of creating the user, the credential has not been created. But if we don't put a question mark here, that means that this when I put a question mark here, it means that this credential field is optional. But if I make it non-optional, then in order to create a user, we need to have a credential, and in order to create a credential, we need to have a user. So it becomes like a cache 22 situation. So when I put a question mark, so it's optional. So now we can create a user without the credentials, and we can create the credentials later and connect it to the user. So this is our schema. Uh, so now now we'll generate our client and with the command npx prisma generate. Okay, I'll install this npm I prisma client. Okay, okay, yeah, node modules add prisma client generated. Okay, uh, so now this is our database. Now we also need to have tables here, user and credential tables here. Right now, no tables there. So one way of doing that is through this SQL editor, where you can have create table user and all of that. But since we are using Prisma, it's an ORM, so it provides migration for us. So basically, this schema that we have specified, based on this schema, Prisma will itself create the tables on our remote host, that is in Superbase. So for that, the command is npx Prisma push. Just give me one moment. Yeah, okay. So I made a mistake in this command. It's not just npx prisma push, it's npx prisma db push. Ah, yes, we cannot reach the connection yet because we haven't specified the connection string. So yeah, we need to first connect with the database with the connection string. So so we go here. Uh, So we can have a direct connection using session pooler. If we were using TG and if we are writing our SQLs manually, then we go for a direct connection with a session pooler. And this will be the URL, the connection string. We'll have to replace this your password with the password that we have saved here. But since we are using Prisma, so we'll go to ORM, Prisma. Uh, we have done these two steps. So there are two URLs, database URL and direct URL. So basically migration is run through the command line. So for migration and everything, we will use the direct URL. And when we access the database through our application, we use the database URL. But for now, I'll copy both of these things. And we had this .env generated for us when we did Prisma init. So Yeah, it already has a database URL, but we'll remove that. We'll put this, and let me just add the password that we had saved. Now, in order to read the variables from our env file, we also need to install .env. So, uh, yeah, here it says it expects that you have installed a Prisma and .env. So let me go and install .env. And now since we have provided the connection string, so let's see now if this works. Npx Prisma db push. So if you remember, this command is going to create the tables that we have specified here, user and credentials, on the remote host that is here. So let me pass that. Npx Prisma db push. Okay. Uh, yeah, so this, I forgot to make one more change. In the env, we have database URL and direct URL. So since we are migrating, we are supposed to use the direct URL. So I will put a direct URL. Ah, yes, it worked. So now your database is now in sync with your Prisma schema. So yeah, whenever we want to make changes to our schema, we use the direct URL. So here in the data source, we have to specify direct URL. Now, yeah, as you can see now, there will be two tables in the table editor, uh, credential and user. So there are two tables, and as you can see, this is the visualization of the two tables, and the user ID in the credential table points to the ID in the user table, all of our fields. So now we have tables ready, so we can start inserting the data. So, we'll first create a module called config, and we'll have I can refer to database URL directly through process.env wherever I want, but it is a good practice to have all the environment variables in a config object. So, and we can export this object from this module. And in order to these environment variables are currently on disk, but in order to load them in the environment, we have installed .env, so we can use .env, or I prefer using .env CLI, so I'll install that. Yeah. uh, as you know, like sometimes you have different environments, like this is development. So in development we have an env file that that we then read it into our environment and then process what env reads from it. But in production we might not want to have an env file on the disk. So instead of hard coding, what I can do is, in my dev script I can add .env dash e. I specify the name of the file where our environment variables is, that is .env, and then I call nodemon dash dash index.js. And so this is the config, so it should get loaded. So let me log the config. And yeah, npm run dev. Okay, it is listening, but it did not log the config. Okay, yeah, I haven't imported the config. Okay, so in index.js, okay, I haven't added the .js suffix. Yeah, now it should be able to load it. See, so now it's printing the connection string. So it is reading the environment variables into an object, and this is our connection string with a password and everything. So now we have a connection string, so we can now create a Prisma client that will connect to the DB using the connection string. So I'll create a new module, Prisma client.js. So we'll import uh, Prisma client from the generated code. So earlier when we did npx Prisma generate, it generated a client for us that is inside node modules. So that is what we are importing. Yeah, add Prisma client. See the first, yeah, this was generated when we did npx generate earlier. Npx init, and yes, npx Prisma generate. When we did this, we had to install Prisma slash client, and then we called npx Prisma generate and generated Prisma client to node modules at Prisma at client. So this that was generated at that time. That is what we are importing here. And we need our config. So yeah, config. And we also need a Postgres adapter. So it is Prisma PG. This is a Postgres adapt. PG stands for Postgres, and Prisma PG is an adapter for the Postgres library for Prisma. I haven't installed Prisma PG, so let me do that. Yeah, again, one moment.
Ankur, I think I would like to pause and come back. I wanted to check to see if anyone had any questions on the homework we can touch on, and then we can swing back to this. Does that work?
Yes, yes, that works. Yes.
So, how did people enjoy the homework? Do they like Prism or Prisma? I got one thumb, just one. Okay, two. All right. That's basically consensus. All right. Uh, has anyone else used an ORM before? No? No? Okay. All right. There's lots out there. Oh,
Hi. I have used the ORM before, but with another programming language. It was with PHP. Um, just it was some modules from Laravel in our projects. So it's kind of this, but a little bit another approach. So there was migrations was separated from ORM, and I'm glad that here migrations like they combined with the ORM, so it's not two different things.
good. Cool. I didn't even think about PHP and ORMs. So that's cool.
Yeah.
Um, okay. Any questions on the homework assignment we want to kind of dig into? I'm going to give people some time to kind of speak up. All right. I got two no's, which is consensus according to my logic. Um, okay. All right. Apologize, Hakur.
Yes, yes,
Continue.
yes. Yeah. I'll uh, yeah, I'll start sharing my screen. Um, okay. Actually, this is the I forgot the name of the proper module, so it's actually at Prisma slash ADAPT adapter dash PG. Yeah. So this was the correct name. I thought it was Prisma PG, but yeah, it happens. So now we have installed the adapter. So yeah. So we first initialize our adapter, Prisma PG, and here we pass our connection string, config dot a connection string. We now create a Prisma client, and we pass in this adapter. And this module will export this Prisma client. So yeah, so this is a centralized Prisma client. So all of our modules will use this, and also an important thing is to add a shutdown hook, because like once this when this module is imported, it will create a connection with the remote host, and when we stop our server we want it to like clean up the resources and empty the connection. So for that, in index.js we'll have process dot on second um, we'll have an async function shutdown. We'll print shutting down. Uh, we won't require console here. We will import the Prisma client. Prisma client. And we have await Prisma dot disconnect. This will ensure that all the connections are cleaned up. Prisma dot connect will be called when we create the Prisma client. Now we are disconnecting it. And we have we'll exit with an exit code of 0. Exit code of 0 indicates normal termination. So this is the usual termination. If the exit code is 1, -1 or something else, that means there was an error and that's not normal termination. And yeah, on sig init, we'll call this function. And also on sig term. So sig init is the signal given when we press Control C. So at that time, this shutdown function will be called, and sig term is when we put this in a Docker container. So the Docker container will send the sig term signal. So for both of these signals, we shut down, and while shutting down, we make sure that Prisma disconnects. We wait for Prisma to disconnect, and then we return the process code, exit code 0. So I'll save this. Let's see if it runs. Yeah, and I'll now do Control C. And see, shutting down. When I did Control C, shutting down. So it's calling this function now. So now we have our Prisma client, so we can start modifying our repositories so that it stores the data in the tables that we just created here, credential and user. Uh, but before doing that, one major thing that we need to do is we need to make our handlers asyncs. Right now, our handlers are not async. So what they do is they block as you know, Node is single threaded. So whenever they are waiting for a response from the database, the Nodes wastes time not doing anything else. So while waiting, Node can work on other requests. So for that, we need to make this async, and all the database calls we have to make uh, yeah, here. So we need to await all the database calls, because these database calls will also be async. So while Node waits for this database call to complete, Node can like work on other requests. Same with bcrypt. Bcrypt is actually a very expensive operation to hash. That is by design, so that it takes time for an attacker to hash passwords. So it is better to move it off the main event loop and pass it to the background thread. So we'll do await bcrypt dot hash, and instead of hash sync, I'll just use hash. So yeah, it returns a promise, bcrypt dot hash. Okay, and again, while saving, we also want to await this. If we don't write await, and if we make save async, which we are not going to do, then it's not going to wait for the save operation to complete. Save operation will start, but this will, before save operation is complete, this will return the status code created to the user. So yeah, similarly in the get user function, we will put await here. And Also in our middleware, we have to also make this async. Wait, compare sync. So compare. Wait. And yeah, there are no database calls after this. Okay. So now we'll make these functions async. Okay, let us verify everything is working. I'll do npm run dev. Okay, yeah, yeah. So see, it is working, but I want to show that error that I was having. So uh, let's say we here I remove the await. So now repo.save is an async function. It returns a promise. So the repo.save will return a promise. That promise is discarded. We don't wait for that promise, and we send the created as it is. So let's see what happens now. Okay, yeah. So it creates that, but here it is fine. But if we remove this as well, I think there will be an error. I think I want to recreate that error because I learned it the hard way. That should be the important thing is whenever there is an async function, you have to write await. In other, I mostly use Go. So in Go, like the compiler will like stop you if you don't write await. But since JavaScript is not a compiled language, so if you forget to write await, it's like a real pain to debug. So yeah, we have written await for everywhere. So now, yeah, I'll start working on user repo. I'll comment this and we'll import our Prisma client. Prisma client. We also don't need this because now database will provide the ID. Um, I'm going to comment all of that, and now we're going to have const record is equal to Prisma dot. So here you can see credential and user. So we had specified two models, credential and user. So we'll go user dot create and and the data is info. And yeah, this is also an async function. It returns a promise. So yeah, we have to like await this and record. So yeah, this should save the user, and we'll also implement the same for here in the credentials. I'll again import Prisma client. Prisma dot credential dot create data credentials Yeah. Okay, now I'll try to create the user. So I have updated the creation paths in both the repositories. So let's see what happens. Hmm. Okay. Hmm. So in credential.create, in the data we have email, we have hash, we have ID. Okay. Yeah, instead of ID, this should be user ID. Okay. Okay. Um, So I'll destructure credentials. That is email, HASH hash, and ID. And you have email, but the field name is user ID, and that should be ID from the credential. Yeah. And yeah, so see here you can see the record Jane Doe. So when I made this request, it saved the record into the database, but there was an error while creating the credential. So see, the credential does not exist, but the user exists. So now when I try to like create it again, I will get an error invocation, and yeah, here see, unique constraint failed on the field email. So if you remember, I had pointed out earlier that we were able to like register it multiple times. But now since we are using a proper database, so the database will not allow the same user to have, will not allow different users to have the same email because we had put the unique constraint on the email. So we are getting an error. So what I'll do is I'll delete this record here, delete one row. And now let me try again. Yeah, see, so it was created ID 3, and this time in the use as well as in the credential tables. Let me reload this. Yeah, see, as you can see, there is a record Jane Doe created at, updated at, and here are the credentials. So see, this is the user ID. The user ID is 3, and it is referencing this user ID 3. So we have the data in our database. Now, so we have the creation path is done. Now we will go to the second part, that is getting the user's info, where we provide the username and password. So these two functions in both the repos, the get function in both the repos, we'll implement that. So let's start with user repo. So I'll comment this, and const record prisma dot user dot find unique, where id is equal to id. So we are using ID as the primary key. So that is why we are using the function find unique, where ID is equal to ID. And I'll put await here, await. And yeah, and then we'll just return the record. And in the credential repo, similarly, I'll comment this out. And Prisma dot credential dot and unique where email is email. So we also had put a unique constraint on the email. So this will like get the credential record by matching the email. I'll again put await here. Uh, Now while returning, we return email as record dot email hash as record dot hash and id as record dot user id, because id is the id of the credential, but we want to return the id of the user. So that is how we return that. I'll save this. And, and see, this is also working. Uh, so yeah, we are able to like save our data on the database. So yeah, that was pretty much my demo. Yeah. Do you have any questions?
All right, thank you.
Yeah.
Let's see. Anything else anyone wants to talk about? Does anyone have anything they like about Prisma in particular?
I think it's kind of nice to be able to deal with things like, with information as though they're objects. I guess it's a bit better than having to like write out the SQL strings and worrying about the syntax.
Yeah, I mean, who here, with a thumbs up from reaction, who here likes writing SQL rather than objects? Ah, there's one. I knew there was going to be one. Okay. I guess what about any other features out there you guys like? How about the relations? Anyone have any thoughts on those? Thumbs up. That's good. That's good. Um, another thumbs up. One thing to note, like with ORMs, is like it's good to learn any ORM because you can actually apply it to a lot of the concepts transfer to other ORMs and other languages. So it's like a good just overall skill to kind of learn. Um, yeah. So okay. Well, feel free. I'm gonna hang out for the next couple minutes. If you have anything you want to ask, feel free to kind of speak up and go through it. So okay. Thank you all.
Yeah, I'll see you next week. Bye bye, everyone.
Bye.
Thank you.
Thank you.